Hello, GCC. This is our last video for Chapter 11. We are now going to explore the limiting reagent concept. So typically in chemistry, you add two reactants together to make a product or two products. So the thing is, when you're adding these two reactants together, typically one of them is going to run out first. It's really hard to get the exact perfect amount of both reactants together so that they run out at the same time. So usually when we're adding two things together, one of them runs out first. It's like making a recipe and you run out of sugar. You can't cook anymore because you ran out of sugar, even if you have more flour. So we call the reactant that runs out the limiting reagent because it limits how much you can make because you ran out of it, so you can't make anymore. So it is the limiting reagent. Now, the other chemical, the other reactant, is still there, but there's nothing for it to react with. We call that reactant the excess reagent because it's still there, it's in excess. The limiting reagent limits how much product you can make because you can't make any more products once you run out of it. So let's explore this using an analogy. Let's pretend you want to build two-door race cars and you have 15 car bodies, you have 64 tires, and you have 28 doors. How many cars can you build? This is a great example of critical thinking here. It helps to have a quote reaction for building the race cars. So to make a race car, you would need one of the car bodies, you would need 4 tires and 2 doors, right? Pause and see if you can figure this out on your own. It's a great question. Okay, so there's kind of a mathematical way to go about this. Let's look at it real quick. We're going to start with each of our ingredients and convert to cars. So we had 15 car bodies. Let's start with 15 bodies. How many bodies do you need to make a car? Well, just one. It's a one car, one body ratio. So we can build 15 cars based on using the bodies. We have 15 car bodies, we can make 15 cars. Now let's examine the tires. We have 64 tires. How many tires do you need in a car? Well, 4. So it's a 1 car to 4 tires ratio. Tires cancel out, we're left with cars. 64 times 1 divided by 4 is 16. So based on the tires, we can build 16 cars. And last is the doors. We had 28 doors. How many doors do you need in your race car? Well, 2 doors per car. So we got 28 doors. One car contains 2 doors. Doors cancel. We're left with 28 times 1 divided by 2 is 14 cars with the doors. So now, which is the correct answer? 15, 16, or 14? Well, think about this. Can we build 16 cars based on the tires? Yes, but what about the bodies and the doors? No, we don't have enough doors to make 16 cars. We don't have enough bodies to make 16 cars, so it's not 16. What about 15? Well, we have enough tires and bodies to make 15 cars, but what about the doors? We're going to run out before we can make 15 cars. So the answer is 14. We can only build 14 cars because we run out of doors after that. We don't have enough doors to build 15 or 16 cars. Doors are the limiting reagent. Tires and bodies are in excess. Okay, so think about that. Doors were the limiting reagent. Bodies and tires were in excess. All right, now let's apply this to chemistry. How many moles of ammonia can be produced from 3.08 moles of hydrogen gas and 2.45 moles of nitrogen gas? What is the limiting reagent? What is the excess reagent? So here we go. We have nitrogen and we have hydrogen. We put them together and they make ammonia, NH3. And this time I've told you 3.08 moles of hydrogen gas and 2.45 moles of nitrogen gas. but I'm wanting to know how much ammonia can I make. So we're going to do two separate problems based on each of the starting amounts, just like we did on the previous slide. We're going to start with 3.08 moles of hydrogen gas and calculate how much ammonia we can make. Then we're going to do 2.45 moles of nitrogen gas and calculate how many moles of ammonia we can make. And then we'll examine those two answers to see which one makes sense. Here we go. 3.08 moles of hydrogen, and then our mole ratio is 2 moles of ammonia to 3 moles of hydrogen. Again, that's from the balanced reaction. We can make 2 ammonias when we have 3 moles of hydrogen. So it's a 2 to 3 mole ratio. Moles of hydrogen cancel out. We get moles of ammonia, and it's 2.05 moles based on the hydrogen. Now let's start with the nitrogen. We have 2.45 moles of nitrogen. The mole ratio is different with nitrogen. We're still going to make 2 moles of ammonia, but we only need 1 mole of nitrogen to make that. So it's a 2 to 1 ratio. Moles of nitrogen cancel out. We got 2 moles of ammonia on top. We can make 4.90 moles of ammonia. So which is the correct answer? We have 2 calculations and 2 answers. Well, do we have enough hydrogen to make 4.90 moles? No, we're going to run out of hydrogen when we get to 2.05 moles. We're going to run out of hydrogen first, right? So we can only make 2.05 moles of ammonia. We will run out of hydrogen at that point. We don't have enough hydrogen gas to make 4.90 moles of ammonia. Hydrogen is the limiting reagent. Nitrogen is in excess. All right, hope that makes sense. That is the end of chapter 11. All right, have a great day, GCC. Bye-bye.